Alright guys, this is solving quadratics using square roots. Sorry I'm not here, I'm sick. I should be here tomorrow. On Friday we solved quadratic equations using a graph. Okay, so remember what that looks like is that if I have a graph, then my two solutions are going to be, or also called zeros, are going to be where the parabola crosses the x-axis. Okay, those 2 points. Okay, what we're going to do now is we're going to do a very simple equation. Okay, x squared equals 4, and we should all be able to solve this thing. There's two values of x that make this equation equal 4, and you could probably even do them in your head, but if you can't, the opposite of squaring something is always the square root. Okay, and so the square and the square root cancel, and it would be x equals, and you're always going to have a plus and a minus answer once you do this, and it's going to be plus or minus 2. Okay, so our answers would be x equals 2 and negative 2. Okay, you can write it both of these ways, but this is the whole point, is that we're going to solve these equations by using square roots. Okay, so example A. Feel free to pause this at any point if you need to write stuff down. Letter A. Okay, x squared minus 4 equals 0. Okay, so notice this equation. You're going to solve it just like you would any equation. For x, we need to get x all by itself. Okay, so we need to do the opposite of minus 4, which is add 4 to both sides. And the 4's cancel out, and we'd have x squared equals 4. And now it looks like just the problem that we did up top. Okay. Once the squared is all by itself, or the x squared is all by itself, we need to square root both sides, and x equals plus or minus 2. Okay, positive and negative 2. I want you guys to try B with the same process. Pause it if you need to. I'll just do it without talking. Once the squared is all by itself, we can square root. Okay, so positive and negative 5. Let's flip this on the back side. Okay, so you're going to hear me say this a lot, okay, is we need to get the x squared all by itself. Okay, so let me rewrite this. There's two things we need to do this time. We need to get rid of the 16, first off, or the minus 16, and we need to get rid of that 9. Okay? And then this x squared would be all by itself. So we're going to add 16 to both sides. So that cancels out. Same first step as the one on the front, or as example A. And now we have a 9x squared equals 16. Okay? The next step is to do the opposite of multiply by 9, which is divide by 9. So the 9's cancel out, and now finally I have x squared all by itself, and 16 over 9 you can turn as a decimal if you want. I'm just going to write it as a fraction because both of those are perfect squares. Okay, so when I square root that number, it's just going to be the square root of 16 divided by the square root of 9, which is 4 divided by 3. So it's a positive 4/3 and a negative 4/3 are our answer. Okay, you guys try B. Pause the video if you need to. I'm just going to do it silently. Notice that the square root of 1 is still 1, and the square root of 81 turns into the 9. Okay? Example C is going to look the same, except for we're going to find out really quickly that it doesn't work. Okay, let me show you why. Okay, when we have x squared plus 1 equals 0. Okay, the first step is going to be to subtract 1 on both sides. And then we'd have x squared equals a negative 1. And this is the point at when we square root it. And whenever you square root a negative number, okay, there's never two numbers that multiply together to equal a negative number. For example, like 1 times 1 is a positive 1, and a negative 1 times a negative 1 also turns to a positive 1. So there's no number that is ever going to equal negative. And so whenever there's a negative under a square root, it is no real answers. And we'll talk about where there's things called imaginary answers that we'll talk about next chapter. Okay, so B, you could do the same thing, and it'll end up being a negative under the square root, which means the same answer, no real answers. You can pause it, try it. I'll do it silently. No real answers. Okay, last example, and we even got a bonus example here that I'm going to have you do. Actually, I think that's going to be enough for today, and we'll finish the rest tomorrow. I love you guys, as number 20 shows, but what I want you guys to do is just finish the assignments that you can. Whenever you have a problem that has like an x minus 1 or an x plus 3 in the parentheses, just know don't do that one on the assignment. Sorry I'm not here. See you guys tomorrow. Thank you, Ms. Boris.